Let's solve a trigonometry problem related to heights and distances. The problem states that a straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degrees, which is approaching the foot of the tower with an uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degrees. Find the time taken by the car to reach the foot of the tower from this point. So basically, there is a tower, and from the top of the tower, there's a man watching the car, and the car is approaching at a uniform speed. So basically, there is no change in speed. The speed is uniform, and there is an angle of depression from the point from the tower till the point of the car. There's an angle of depression of 30 degrees. So we need to find out the time taken for the car to reach the foot of the tower. So let's assume that this is the tower. So the man is standing on the top of the tower. This is the tower. He observes the car at an angle of 30 degree. So there is a depression here because the car that he's looking at is at a lower level. So we need to draw a horizontal line whenever there is angle of depression. So here the angle of depression is 30 degrees. So let's call this as point A, B. Now the car is approaching towards the foot of the tower, right? After 6 seconds, that is after 6 seconds of time, the car will reach one point where the angle of depression changes to 60 degrees. So this angle will be 60 degrees at this point. Let's call it as point C and this as D. The question is, how much time does it take for this car to travel to foot of the tower from this point? So we need to find this time from C to B. So we have time taken by the car to travel from D to C, which is 6 seconds. We'll have to find out this. Let's call this as T1. We'll have to find T1. Now using alternate angle principle, side AD, the alternate angle for side AD is this one. It's 30 degrees. Similarly, there is side AC, which is having an angle of depression, which is 60 degrees. The alternate angle is this one, 60 degrees. It's going to be the same. Alternate angles are going to be same. So we have two triangles here. This is one triangle, triangle ABC. There is another triangle, triangle ABD, the bigger one. So if we have to find time, so we need to know the speed formula. What is speed formula? Speed is equal to distance by time. So we have to find time taken. If we have to find time taken, then we need to know the distance. Speed we don't have to know because speed is going to be constant. So it's going to be the same whether it travels from D to C or C to B. So we have to find the distance. To find the distance, we'll have to use the heights and distances technique. So we'll take first triangle, say triangle ABC. Triangle ABC, we have 60 degree here. So we'll take tan 60. Reason we'll take tan 60 is because we need to find the distance here. If we know the distance BC, right, then we will get the time taken. So we have to find this distance BC. So tan 60 is opposite by adjacent, and that is AB by BC. AB we don't know, and BC also we don't know. So tan 60 is √3. We'll say AB is H. So we'll call this as H by BC. Let's call this as equation 1. Now let's take triangle, the bigger one, ABD. ABD. The angle that we have is 30 degrees over here. So tan 30 is equal to opposite by adjacent. What is the opposite side for this? Opposite to the angle 30 is AB and adjacent is BD. What is AB? AB is H and BD is BC plus CD. BD is BC plus CD and tan 30 is 1 by √3. 1 by √3 is H by BC plus CD. So this will give H as, we'll move √3 to the other side. So we'll get This is nothing but h by BC plus CD is equal to 1 by root 3. We'll shift this one to the other side. So we'll get h is equal to, when this goes to the other side, it's going to come in the numerator. So BC plus CD by root 3. This is equation 2. Now from 1 and 2, height of the tower is going to be the same. LHS is same in both equation 1 and 2. So if LHS is same, then right hand side also has to be same. So from 1 and 2, LHS are equal. So RHS is equal, which is nothing but root 3 BC is equal to BC plus CD by root 3. So we'll take root 3 here. So it's going to become root 3 into root 3, which is 3 BC is equal to BC plus CD. If you simplify this, you take BC this side. So it's going to be 3 BC minus BC is equal to CD, which is nothing but 2 BC is CD. Let's call this as equation 3. Now we will have to use the speed distance time formula, and using these expressions and using these values, arrive at the time. So we got 2 BC is equal to CD. Speed taken by car to move from D to C is distance by time. What is distance here? CD. Time is given as 6 seconds. Similarly, speed taken by car to move from C to B, that is distance is BC. Time we don't know, so it's T1. This is what we have to find out. T1, time taken to travel from C to B, because B is the foot of the tower, and time taken by the car to move from C to foot of the tower is what we need to find out. So let's call this as equation 4 and equation 5. From 4 and 5, speed is same, right? The speed of the car is moving at a uniform speed. The car is moving at a uniform speed from D to B. There is no variation in the speed. So speed from D to C and speed from C to B is equal. So LHS is equal. LHS is equal. So RHS also will be equal. What is RHS for equation 4 and 5? CD by 6 is BC by T1. So both of these are going to be equal. Now CD, from the earlier calculations using tan 30 and tan 60, we got 2 BC is CD. Let's substitute it here, right? So we'll substitute CD as 2 BC. Substitute CD as 2 BC. We get 2 BC by 6 is equal to BC by T1. BC here and BC here will get cancelled. We'll be left with 2 by 6 is equal to 1 by T1. This will get cancelled. So we'll get 1 by T1 is equal to 1 by 3. This is nothing but T1 is equal to 3 seconds. So time taken to travel by the car from C to B is 3 seconds.